Welcome to another episode on my Raspberry Pi 1 running Raspbian Linux, and using some electronics in order to read signals, values from a fischertechnik light dependent resistor, photoresistor, and an ordinary one via an analog digital converter to the GPIO of the Raspberry Pi 1, and then a few probes connected to data, clock data, and slave select. Last time I showed you schematics, and after that I changed the layout. So here I used GSham schematics from the GNU electronic development applications, and it's often I use Scilab, but Scilab doesn't have symbols for a photoresistor, not that I can find them anyway. So the schematics is the ground voltage 5 volts, no, 3.5 volts actually, 3.3 volts, although it can have 5 volts, no problem about that, and 100 kilo ohms resistor. Let's say this is the fischertechnik version and this is the ordinary version, and then between here and here is the or actually if you look very closely it's from somewhere here, but it doesn't really matter, the connection between the analog to digital conversion to the GPIO. And this is a very generic symbol. There are specific symbols, but they don't match the MCP 3008 that I'm using. There are many different versions. Anyway, this is how it looks like now. Last time it was kind of a mess. I tried it with buttons, didn't work out. I got two incidental values, so I'm very curious what will happen now. One other thing that I still have to investigate, by the way, is the reason why the Raspberry Pi seems to reset if I try to measure on the pins here. If I touch this or any of the pins here or here, it suddenly reboots. Why? I have no idea. Anyway, that said, let's see if something works out. Suddenly, well, although I clearly see here some peaks and spikes, let me try to change the timing. Now it's 5 microseconds. Back to 200, 500. You clearly see some spikes going on. The question is, what are they? Right now you can see them here more clearly than anywhere else. if they come. And it's now 500 microseconds. Let's change this into 5 milliseconds, and yes, you see them here as well, but in value I don't see a thing. Put my finger on it, nothing. Put my finger on this one, also nothing. Oh wait, I have not connected the mass to the crocodile beaks to the mass. So let's see if that is really of influence. Right, so I have now connected all the crocodile beaks to the mass, to the ground, and looking at these signals, are they really actually what they are supposed to be? Well, one to clock, then D out, and one is this CS, and CS has a bar over it, which means inverted, and then we come to the conclusion that this is indeed correct, because without inversion it would be 0. So this is 1 when the rest is yeah, an inverted 0. So that is in itself correct. The fact that I don't have any value is a lot less correct. So let's try to get something out of it, but somehow it just won't work. It's all 0. Also, one other thing is that it has a maximum speed in hertz of 13 million hertz, 30 megahertz. If and then you get into a period of a microsecond. Mere microseconds. So if I turn this back, to say 100 microsecond, what will happen then? If anything. Nothing at all. And this is just too bad. Why? Ah, wait. There was too much flexibility in here. I could just press and it went down. Wait. Huh, no, too optimistic. Yeah, that was too optimistic, unfortunately. I thought maybe it lost contact. But right, and when I do power off and on, so let's run it and see whatever happens. And when I take this one off and on again, but it is really the value that come out of here. Well, that is the problem, and I have not changed any of the contacts here, so I'm still very much at the loss why it doesn't work anymore. And from my other experiment with SPI, I know that it is largely due to connections when it suddenly stops working, but then again all the connections here are completely alright. There's nothing that have been out of connection. So, yet again, how to solve this? I have to come out with a plan. Right, so far all tests have been negative, and the problem now is how to proceed. Unfortunately, I do not have a spare MCP 3008. In other words, the ADC converter. I do have a spare LDR. The question is though, what would it matter? So, on the risk that it goes off, that it completely reboots, I want to measure the voltages that are being delivered. So even beyond everything, I am going to measure the voltage here, which is absolutely nothing. Is that correct? Should I measure anything? Well, actually I should be measuring anything. So what do I measure here? Nothing as well. Nothing either. Do I measure here something? No. Do I measure something here? Yes. 3.3 volts. And I realize that you don't see anything on the multimeter. Anyway, here is nothing. Here is nothing visible. And when I measure here, you see clearly the 3.3 volts. Now, what would I need to see on the blue wire right here, since that is directly connected to the SPC channel 1, channel 0 actually. I think it's worth trying, and if it reboots, well, then it reboots. So we bend it a bit, measure here, nothing. Alright. No reboot yet. So the voltage is absolutely 0. Am I measuring correctly? Well, I can go here on the multimeter to 3 volts measuring. So instead of 30 it will be 3. This will be 2. And then it says nothing either. And here no surprise. But here also nothing. And here also nothing. The only risk is that 3.3 is now off the scale. So let me make it 12 volts. Then I would measure something here. Yeah, that's what I mean. And here there's absolutely nothing. Here it says enough, and here it says. So would that be it? Would that be the problem, that there is absolutely no voltage measured? And it is a 10 kilo ohms resistor, but it did work. So then what's the reason? That is a very good question I have to answer. Did it measure something before? And I have no answer to that yet. Now, the point is still, there is a signal somewhere, or supposedly a signal, but with the multimeter I can't measure it yet. Now what I have done is here a little change, and the change is actually explainable in the schematics that I put between here and here an LED. So let me see if I can quickly put something in it. Alright, even better. So and now this is the wrong direction, but anyway, then you would have why isn't that wire working? Between here and here. So if there is a signal with high enough voltage, then I would maybe see something. Oops, that's the wrong one. So let's see how that ends up. If it ends up, and I see even less now. Yes, now these LEDs are functioning. However, this LED shows absolutely nothing. So if there is no voltage over here, how can there be a signal here? So maybe it is time to measure indeed the resistance here. Because this is leading to nothing. nothing at all. So decouple this one, then I will have to change the multimeter setting to ohms and check for ohms, that is. Now this is connected and this is not connected, so I am going to see, and right here so I'm going to 10 kilo ohms, and then I have to change the setting a bit. But you saw what happened right here. The LED flashed, suddenly not working right now, and I'll try not to obstruct the camera. So if I run the program and I do this, do I then get values, even though shortly? I don't think so. But there is something very odd going on in this circuit. The question is still what exactly, but I think I'm at the right trail now. Yeah, the 10K is maybe too much, but I still have to measure the resistance of this one, and I don't think I need this one. I think, or I should, but if it is a 10K, if this is a 10 kilo ohms setting and the resistor is 10 kilo ohms, so why doesn't it show? That is a very good question. Right now kilo ohms 100, so it should be somewhere. If this is 100 kilo ohms, it should be somewhere there. So let me once again check. Yeah, this is about the value I could expect. 100 kilo ohms. So back to 10 kilo ohms. Yeah. Although still strange because it doesn't have the full scale. So I think here is a problem. Last part for this episode. I have put the multimeter on setting of 1.2 volts, and this means that I will measure from, let's say, this point, which is connected to earth, to ground, oops, and then I will measure several other points to begin with here, and here it gives a very low value even on the 1.2 setting. So when I measure right here at the fischertechnik LDR, it gives the same reading. So there is an extremely low. So right now this is 1.2 and it says a fraction above 0. And the big question is that normal? Well, to be honest, I don't think so. But how to solve it? That's a very big question. If I replace that resistor, will it give me actual values, or values that I can use anyway? It's hardly possible to use these resistors because they are 800 ohms and not 10 kilo ohms. So that's going to be very tough. Then again, if I say okay, put everything on it, full power, what will it do? Will it do anything at all? What is the entrance level of signal that will come to the zero channel? I think that is a very interesting question. Let me take a look. This is the schematics. And what is the actual? Well, I don't see here the real data of it, but it needs some voltage to get the value through, and the voltage now is way too low to get that to happen. So I think that is the problem. The chip isn't broken or anything, but the value, the voltage is just way too low to get something done. Right now I'm at the very end of this episode. Next time I know where to continue, and see you later. Thank you for watching. If you like this video, please subscribe to my channel if you haven't done so already. Like this video, give it a thumbs up. Follow me on Twitter, retweet and like. Follow me on Instagram and like. Please donate to keep the videos coming your way. And this is obviously going to be continued. Bye bye.